I am working through this question for the students who are preparing for the further mathematics exam and also the writing the A-level mathematics booklet. So here we have a typical acceleration variable question. In the exam there are two formats. One is this format, and the other format is the vector variable format, where you are given I and j's in the question and you are required to differentiate it. So a particle moves along a line and its position at time t is modeled by the equation given. You are required to find the distance between the two times when the velocity equals 0. How do we find the velocity from here? Now, x is the distance given as the equation here. So when you differentiate x, you're going to get the velocity. So we can work from here. So velocity from here, v, let's write that in red. Okay, the velocity v is dx dt. And we want to find the values of t when the velocity equals 0. So let's differentiate this. So we're going to have dx dt equals 12t squared minus 98t plus 176. So our job now is to equate the velocity to 0 now, and then we factorize it. So we have 12t squared Okay, so our job is to factorize this equation. So let's divide through by 2 to make it much more simpler. So we would have 6t squared Okay, so I'm gonna just help those people who struggle to factorize these equations. Let's multiply 6 times 88, and what we get there is 528. 528. So we want the factors of 528, and when we add them together we should get 49. So we could do 16 times 33, and when we add 16 and 33 we get 49. If you notice, it's minus 49, so this should be minus 16 and that should be minus 33. So we're going to rewrite, instead of writing minus 49t, we're going to have 16t minus 33t. It's the same thing as minus 49. So we rewrite the equation as this equals 0. Okay, so we would have 6t squared. So instead of writing 49, I'm going to write minus 16t minus 33t, okay, plus 88, and that equals 0. So nothing really changes there. If you notice, this is minus 49t still. We're going to insert some brackets in this, and then we can factorize it. We find the common factors there. So in this, where the bracket there is, the common factor there is going to be 2t. So we get 3t minus 8. And the common factor in here is going to be 11. Yep, so that's minus 11 there into 3t. This minus sign is going to change that plus to minus, so that's minus 8, and that equals 0. So we would have 2t minus 11 equals 0 or 3t minus 8 equals 0. Okay, so so it means that 2t would equal to 11. So t equals to 11 over 2. Or 3t, we would have 3t minus 8 equals to 8. Therefore, t equals to 8 over 3. So now we want to find the distance between the 2 points when the velocity is 0. So between the 2 times. So we have the times here. So all we need to do is substitute these values into this to get the distance. So when t is 8 over 3, I've substituted there and I got x as, let me see what we get there. So we substitute, so we have x as a distance here. So wherever we have t, I'm going to substitute 8 over 3. So we would have 4 into 8 over 3 cubed minus 49 t squared. So t is 8 over 3 squared. And then let's just go through this to show you what's going on there. Plus 176t, and t is 8 over 3. Okay, and minus 10. So when we hit the return key, we get 186.74. So x is 186.74 for this distance. 186.74 meters. So let us work out the value of x when t equals 11 over 2. So by substituting 11 over 2, we get 141.25 meters. So wherever we have t, we replace it by 11 over 2. So we would have 11 over 2 cubed minus 49 times 11 over 2 minus 49 times 11 over 2 squared. Okay, plus 176 times 11 over 2, so 176t, and then minus 10, and that equals to 141.25. So x, the distance is 141.25. So it says find the distance traveled between the 2 times when the velocity is 0. So the distances are here, so 186.74. So we need to find the difference between these two. And so the difference there is going to be 186.74 minus 141.25, and that gives us 45.49 meters. And that would be the answer. Okay? 45.49 meters. So here ends this question. In the next tutorial, I'll do another question, which is going to be the vector variable question, where we have them in I and J. Okay.